Okay, well, this is what you would see if you drop in to one of our experiences. You start off in the environment you'll be working in, usually. Sometimes we'll start you off in a little bit of a different area, but this is generally what you'll see. You'll notice here that we have a menu that gives you some options. A lot of our clients need English, French, Spanish language options, so we have those there. As well, you'll see the movement system. There's two generally big movement systems that we use with our clients. The first is called smooth movement, and this really allows us to move around while either seated or just standing still. And if you see, I'm moving my view around by just moving a little joystick on one of my controllers. The other option is a teleport option, which allows us to hop around the environment. It's less immersive, but some people do get motion sickness when they're in VR. So we have a lot of ways to compensate for that. And one way is to provide different movement options. But let's get started. So I'm just going to come over here and poke the start button.
Your task is to connect a new residential triplex and then install the meter to energize the service. Your PPE, rubber protective equipment, tools, and testing equipment have been inspected and verified safe to use.
So what are we hearing there, George?
You'll be doing
so this is a narration that you'll hear in almost every experience. We almost always have an opening and closing narration, and that narration gives you a quick idea of the things that are different between the scenario as you would have it in the world and the scenario in VR. For example, the nice lady just told us about our watch. And so if I'm going to look up here and we can see that I've got a watch in front of me. The watch allows us to do two big things. One is it gives us a little hint as to what we're supposed to be doing next. And if I push the lower crown here, you can see that it gives me access to my tool belt. Now, my tool belt gives me access to tools that I'm going to need when I'm up on these high spots, and normally those would be attached around you, but of course in VR, as you'll see when I put on the safety equipment, having access to the belt around you can be a bit of a problem. So we put them all here where you have access to them. A funny little thing about this watch, we didn't put the time on the watch for the longest time. We just had it as sort of a placeholder where you could push, and it was late at night one night when we were all up testing and trying to get through a big project, we realized we really should have the time on the watch. And so we actually put the real world time. So we're Eastern time here, and this presentation is going out at around 11:25. So that gives you an idea of the watch. Now, as I said, she was telling us about it. This experience is designed for people who kind of know what they're doing. So we're not getting a lot of voiceover and giving us exact instructions, but we'll see an experience like that in just a second. So what I'm going to do is I'm going to get started here. The first thing we need to do is get into this box. Now, this box, everybody has one of these on the side of your house. It's where your meter goes. There's a meter here. And normally, you never want to do what I'm doing. This is one of those things that should only be done by a professional. And one of the great things about VR is I can just stick my hand in here and there's going to be no problems. It's a really great way to do what we call training without consequences. You can get it wrong and nobody gets hurt, including yourself. So for right now, I'm just going to reach in here and check to make sure all these bolts are nice and tight. And then it's giving me another great thing that we can do in VR. Normally, you'd have to have like a pad or some way to figure out, okay, did I get all of these checks done correctly? And what we can do is we can actually provide you with the checklist in VR so that you can concentrate on doing the task. So speaking of that, let's attach some probes and we'll get our meter. And what we want to do is pull the trigger here and test, and what we want to make sure is that there is no connection here. So we've just checked that one. Let me move my probes down. Check this guy, and as you can see, every time I do a check, it's being taken off of the list. Do the check again, and another one goes off. And then we'll go down here and we'll do all of these. So we'll get rid of that one, this guy, do the lower two. Last check, and we'll check the neutral to the neutral. There we go. So I'll put him down, pull these guys off, and now it is time to go up the ladder. So we're going to
just a quick question there, George.
Yeah.
If you were to have done that task wrong, would you have gotten a notification?
Usually, there are two different ways of doing that type of reinforcement. We can either pop up a notification that says you're doing something incorrect, or what we can do is just not allow you to continue until you have completed the task correctly. Most people go for allowing people to do it incorrectly, and then we record that in the telemetry, because that gives you an idea if they've actually learned the task. We generally have 3 different styles of tasks that we do in the same environment. The first one, which we often call a crawl, is a very hand-holdy, do this, now do this, now do this. The next step up with is something like this, which is a walk, where there are some things that tell you what you're supposed to be doing next, but we don't give you a lot of feedback. And then the last one, which is we often call a run, which is the type of thing that is used for evaluation. You don't get anything. There is no kind of feedback for you. You just have to try and do the task. And once the task is done correctly, the testing person will let you know that it's time to take off the headset, and then they'll get their big checklist of things that were done incorrectly and walk you through it and why it's like that. So we can go anything from us giving the feedback to the learner right to giving 0 feedback at all and having that all on the tester. So let's get up there.
While George is getting the ladder set up, I just want to let all the viewers know. So we run at 90+ frames per second. Just when it's coming through the stream, it might look like a little bit more choppy, but yeah, don't worry. When George is in there, it's 90+ frames per second, very smooth. So yeah, just take that into consideration.
Yeah, when we are running off of a desktop computer, we can actually push upwards of 120 to 200 frames per second. Unfortunately, if we're running directly off of the headset, usually that's a little lower, as Matt said, around 90 frames per second. But just like all of us have experienced on our Teams or Zoom meetings, the speed of camera updates is a lot different for me than it is for you guys. So I'm going to put on my PPE because I'm going to need that before I go up that ladder. So I'm going to put on my belt, and then I'm going to swap out these just regular gloves for some high voltage ones. So there we go. I'm all ready to go up. So one of the things you may have noticed is that even though I was walking around, when I went to go up the ladder, I just kind of teleported up here. We found that moving horizontally in VR is usually quite comfortable for people. Changes in elevation can be quite scary and jarring. So we always try and make it so that it's easy to concentrate on the task and not being in VR, scared in VR. So I'm gonna just turn around in my belt a little bit here so we can see, I'm not quite as high up as I'm going to be, but we can start to see what the visual is like when you're up this high. And this is a great thing to figure out, is someone scared of heights? Can someone actually work at heights? Because this is when you want to find that out. In a classroom with a headset on in a safe environment, again, it's training with no consequences. The last thing you want is someone to freeze up in a bucket, 150 feet up working on a pole, rather than finding that out in a classroom. So let's get these hooked up. I'm going to need some tools, so I'm going to bring up my tool belt. First, we'll need to strip the insulation off, and we'll get the insulation stripped here. And then I'm going to need to clean up those connections. So I'm going to get out my brush and give those all a little clean. And then the next step here is that we're going to get some of these impact connectors. These are really neat connectors. They allow you to give a very high amperage, high voltage path while using a relatively small connection. Let's get a wedge out here, this nice big metal wedge that goes in between them. And then we get to do the fun stuff, because the impact system uses a special tool, and that tool uses the same type of blank cartridge that you'd see in like a concrete nail gun or something like that. And it uses that to be able to compress the connector down. So let's put our connector on here, and my grip strength is not going to be able to do it. So let's get a hammer and give that a good whack. And that has seated that wedge in. And now, of course, we don't want anybody to get hurt. So let's grab a cover and put that on. And then we'll quickly do the whole procedure again for the other leg. So we'll get ourselves a connector, connect up the wire, get ourselves a wedge, put the wedge in, get ourselves a shell, put the shell in, let that close up. Now, one thing you'll notice is that
George,
I'm doing, oh, go ahead.
George, when you talked earlier about muscle memory, I'm seeing you do the same basic task twice in a row. Is this the kind of thing you were referring to?
This is exactly what I'm referring to. This type of muscle memory can vastly increase the speed and the competency of the people you're training. As a rule, we as developers do these things over and over again. So we tend to build up the same muscle memory that someone who is doing the experience would. For example, in the very first hydro experience, the average time to complete the experience was kind of like 15 to 20 minutes. But as a developer who has done it literally thousands of times, I was able to get that down to about 7 minutes. Now, I'm not saying that I could have done that task in the field in 7 minutes, because there's a lot of things that VR makes easier. I don't have to physically walk around. I can use the little joystick to move. But I am fairly competent that if I had people around me who knew what they were doing, I could point at the things and say, do that next, grab that tool. And I would be able to easily walk them through a dangerous task in a very short amount of time. So here we are up the second pole, and now you can actually see into the backyards. We have various types of backyards and visibilities onto the backyards, because one of the things that you have to do when you're up here is you're checking the lines, you're making sure there's no problems, and you're checking to see whether everything is safe. Because if there's someone, say, coming out here and looking up to see what's going on with the weird person on the pole, you have to be aware that if something drops, or if you know, they are, I don't know, throwing a ball around in some backyard, a kid could easily hit a ball up towards you, and being aware of that type of surrounding is very important. So we're up here, we're gonna do similar to what we did over there, but these are actually lines that have power in them. So we gotta do something a little bit more safe. So what I'm gonna do is I'm gonna cover up these lines with these insulated blankets to make sure that we don't have any problems with those. When we were developing these, we called them the crackers because of their shape and color, but they are just another insulating blanket. And you can see this shows you how you would roll it down to get full coverage. So let's get these guys up as well, and get the second blanket on here, and it will cover up. And you can see again that we're going to do that same impact style connection here. So again, we'll go into our tool belt, we'll get out a connector, put it in, grab the wire. And if you notice, this is the same wire that we did not connect at the other end. So this is the first bonding that we're doing. We're actually bonding up the ground wire, so that we know that when we go to connect at the other end, there's always a ground path for the electricity. And that's the type of weird little fact that you learn when you are doing these. So let's put that guy in there. We'll get out our tool and get, while that's opening, I'm going to get out my hammer. We'll get out our cartridge, put the tool on, and then give it a good whack. Take that guy off, and we're done up that pole. So this is the place where we're going to finish up for this demonstration. But as you can see, we would continue on to work at heights. This gives you a really good idea of the type of experience that you would be doing. And this is an example of what Donna was talking about with the table that you wouldn't normally have in the field. You might have a toolbox, you might have you know, a little place to put things down, but unfortunately they don't just wheel out a nice table and lay everything out for you.
So if I recall correctly, for Hydro Ottawa, we delivered this scenario. There was also one for connecting houses to the grid at ground level. There was another working with a transformer. There was something with underground cable access.
So, yeah, cable entry. Actually, we'll just take a quick little walk over here. A lot of those other scenarios you're talking about would happen here. So this is a in-ground transformer box, and we have the first scenario we did was connecting this one up to the house as opposed to doing an overhead line. Cable entry actually prepares you to go into a manhole because there's all kinds of horrible gases that can build up underground, and what you need to be able to do is successfully run the tools that would allow you to detect those gases. So during that experience, we again, we placed a table here with all the different steps that you would need to certify the tool to be able to use the tool, and then you turned around and actually used the tool on a manhole cover so that you could then go down and do work in it. So those are the experiences that we have provided so far.